Hi, this is Dr. Wooten. In this presentation, I cover the non-response method of fitting a bivariate probability distribution to codependent variables. So what I've done here is read in hurricane data from the years 2000 to 2009, and I can draw the picture of that. So as you see, there is a definite relationship between wind speed and pressure. However, this picture doesn't really give us a good idea of the frequency distribution. If we look at pressures tend to be high and very rarely are low. If we look at wind speeds, they tend to be lower and are rarely high, which means that we have a codependent variable here. So I created a gridded map here to count the frequencies, and then I took a few choices of colors to represent this, and I chose the rainbow. So what this means is the red areas are highly frequent, and the green areas show a frequency of 0, and then there's a fade in between. So what I'm going to try to do is fit this probability distribution using non-response analysis by creating a variable called unity, which is a column of ones, the length of my variables. Create a linear model of that. In this method, the assumption of independence is not satisfied, and therefore r squared does not represent the percent variance explained. However, it does show that when you predict it, you have a variable that is normally distributed. So using this fact, we can create a function to estimate unity based upon our model and fit the probability distribution to our wind speed and pressure. And then when we consider the plot of this graph, what we see here is in a light line where we predict it to be. I have a better graphic of that. So this is a plot of the distribution. I believe this is the same one. Yep, we have interaction terms between the two. So when you use the method to fit the non-response model, the non-response model yields a probability distribution of the estimation of unity that gives the probability density function of the entire